So this fascinating story started with Aristotle in some 300 years before the birth of Christ, and he was the first to grapple with the many connotations of the concept of energy and to attempt to make sense of its many complexities. And he came very, very close to a scientific definition of energy. And he referred to this concept in his book Metaphysics by joining in and work to form energia. And then he linked that to complete reality. And the verb energia thus came to signify motion, action, work, and or change. So let's step forward and listen to what Richard Feynman has to say. Now, Feynman, of course, was one of the most famous theoretical physicists of the 20th century, and he made the statement that we really don't know what energy is. But then he went on to say that there's a fact, or if you wish, a law, governing all natural phenomena that are known to date. There is no known exception to this law, and it is exact so far as we know. And the law is called the conservation of energy. Now, as we will see in just a few moments, it wasn't until the 18th century that the ideas that Aristotle put forward actually took on some quantitative meaning. And you can see why this is true. We can look at a lot of different mechanical systems. You can look at a ball rolling along a floor, and it rolls along for a while, and then it stops. So you immediately come to the conclusion that energy isn't conserved because it disappeared. And we can take a machine that I have sketched here that is a rod that contains mass, and that rod allows that mass to slide up and down, back and forth. So if I elevate that mass, that ball, that steel ball, to a certain position, and I release it, it will descend down the rod, hit the spring, and return back up. And if I watch that ball oscillate back and forth, I know that initially it had some energy, and that energy initial was, and we'll look at this in quantitative detail in just a moment, it's equal to the mass times the acceleration of gravity times the height that I've elevated this ball to before I drop it. But as I watch it, it oscillates back and forth, but slowly those oscillations decay, and so the final energy is zero. And this is another proof to humans that energy isn't conserved. But the remarkable thing is that if humans could see in the infrared, they would have figured out the conservation of energy 2,000 years before they did, because if I took a picture of this apparatus after I had allowed that ball to oscillate, the rod that it was oscillating on would be glowing warmly in the infrared. And I would realize immediately that what happened was that I converted the mechanical motion of that ball to the motion of the molecules in the rod, heating them up, and they then emitted in the infrared. So if humans could only have seen in the infrared, we would have solved this energy issue 2,000 years earlier. And as I pointed out before, science didn't make progress until the conservation of energy was understood.